Welcome to Classwork 5.4. Today we're going to be solving exponential equations. So the first thing to write down is going to be a simple idea that a to the x equals a to the y. If you know that, you can conclude that x must equal y. I know that seems very simple, but you're going to box that, and that's a very powerful concept that we're going to start with today. So if we look at this question, if I want to use this property, I'm going to leave 2 alone and rewrite 16 as 2 to the 4th power. Now I can use that property we just talked about. That would mean 3x minus 8 should equal 4. 3x is equal to 12. X must be 4. Let's try it here. So I have 27 and 9. So let's rewrite that in terms of 3. Notice I'm using parentheses. That's very important. Now that the 3's are the same for the base here, we want to get rid of them. So I'm just going to erase those essentially. 3x plus 9, that should equal 2x minus 2. So we're going to see x is equal to negative 11. And we're done. Okay, so that's our first example. In our next example, we're going to see that idea doesn't work here, because for 4 and 15, it's not possible for me to combine these in a way or make these the same base, right? Because 4 and 15 don't really share anything. So we're going to use another idea that if a is equal to b, natural log of a must also equal the natural log of b. And this might seem kind of weird. So we're going to see what happens here. Natural log 4 to the x equals natural log 15. So that's what I'm saying to do, right? Now think about why this is helpful. The log allows you to grab that x and move it to the front with the power rule. So now you have x times natural log 4 equals natural log 15. And there's the answer. Natural log 15 over natural log of 4. So if I do the same thing on the next problem, let's add a natural log to both sides. We're going to move that x over. And notice how it's pretty much the exact same thing as before. X must be natural log of 120,000 divided by the natural log of 10. Okay, so first two examples, not too bad. Let's go here. So already I can see a little more complicated. I have an e, I have a 40 over here and a minus 3. So what you want to focus on is this thing right here. You want to isolate this. That's going to be your goal. So I'm going to have to add that 3. And I'm going to divide by 40. So e to the 0.6x, that's going to equal 6. And now I'm in the exact same situation. I can natural log both sides. Now I can move this thing over. Except we should know what ln e is. Ln e is 1. If you forgot that, just write that down. If you're wondering why that is, that's because ln e is saying log base e of e. So that must be 1. So put a big note here in case you forgot. So now I have 0.6x must be natural log of 6. So there's our answer. Natural log of 6 divided by 0.6. Let's go to our final one. This one looks the hardest, but it's actually not too hard as long as we stay organized. We're going to do the exact same thing we just did. We're going to natural log both of these. And let's move the exponent down. And Just be careful when you do this. Make sure you have your parentheses around the exponent. That's going to make it much easier. So again, we're just grabbing those and removing them. Now we're going to distribute. So I'll try to make this as clean as I can. X times natural log 5 minus 2 natural log 5. That's 2x natural log 4 plus 3 natural log 4. Notice how I have x on both sides. So we do want to get those to the same side of the equation. So I'm going to want to subtract that to the left. And I want to add this to the right. So I get x natural log 5 minus 2x natural log 4. That's equal to 2 natural log 5 plus 3 natural log 4. Now that I have my x's on one side, I'm going to factor it. So I have natural log 5 minus 2 natural log 4. That's equal to the right side. And now let's divide, and we are done. 2 natural log 5 plus 3 natural log 4 divided by natural log 5 minus 2 natural log 4. Let's make our nice circle. That's not a circle. That'll do. And we are done here.